So this question in your vectors assignment 4 was on collinearity, and you were having to prove that the points are collinear. So you begin this question by finding two vectors that are parallel to each other, and the way to do that, usually the standard process, is looking at A to B followed by looking at B to C. So to work out the vector that goes from A to B, the standard result for that would be position vector B minus position vector A. That is just the same thing as the coordinates, of course. So you've got 8, 3, 1 minus 2 minus 3, 4. That gives you the value of 6, 6 and minus 3. I'm just going to leave it at that point just now, and I'm going to work out what the other vector is. So to go from point B to point C, what I really want, or what I'm hoping, is that to see that they will in fact be multiples of each other. So result for B to C would be using position vector of C minus position vector of B. So our C here is 12, 7 minus 1, and you're subtracting position vector for B, which is 8, 3, 1. That gives you the answer of 4, 4 minus 2. Now clearly at the moment they don't look like they're a multiple of each other. However, if you think about the sort of common factor of aspect of this, so in this one here, if you can see that there is a factor of 3 running through that, so if you write this as 3 bracket 2, 2 minus 1, and then this one over here, there's common factor of 2, so we would write that outside, so 2, 2 and minus 1. And then at this point you can actually see that they are the combination, or they're scalar factors of the same vector. So what that does tell you is that they're parallel to each other. Now to begin your statement, it will help you if you think about this in terms of a ratio or a fraction version. So A to B compared to B to C on that line would be, so the A to B part is 3 times the length of the B to C part, so clearly the ratio is 3 to 2, and if you cross multiply with that, with the BC, you would then be writing down the A to B will be 3 over 2 times B over C, so 1.5 times, and it is this here, because you've now written one vector in terms of the other one with a multiple involved, that automatically means that they're parallel. So your conclusion, and this is how you begin, is that since A to B is equal to 3 over 2 B to C, what that tells you is that A to B and B to C, so the vectors A to B and B to C are parallel, but B is a common point, so the points A, B and C are collinear, and that's your proof. That's what you're asked to prove, and you need all of that in there. I can't emphasize enough that you must have that the vectors are parallel, so A to B and B to C are parallel. You must have the bit about the common point, and then it's the points that are collinear, not the vectors. So you need to get your communication correct for that question. Now part B was then asking you about to state the ratio in which B divides the length. So state the ratio in which B divides A to C. We've kind of already worked that out, but we'll actually state it formally. So B divides A to C in the ratio 3 to 2. So if you could check your work, make sure you've got that. The conclusion statement is the one to make sure you work on with that, and give yourself some feedback on it if you weren't getting it correct.